Hello and welcome back. Today we're going to look at section 2-4, complex numbers and operations. So we want to look at and determine how we can represent and operate on numbers that are not on the real number line. So what does that mean, not being on the real number line? Well, we know how to take the square roots of a positive number, right? So if we had to take the square root of both sides, we know there are going to be two values of x. X can either equal 4 or x can equal -4. Because if we plug them back in to x squared equals 16, well, we know 4 squared equals 16, and we know that -4 squared also equals 16. So when we take the square root, we get two real numbers. Now, what happens when we take the square root of a negative? Well, we know that we can never take a square root of a negative and get a real number. For instance, if I multiply 3 times 3, or 3 squared, I get back to +9. And if I squared -3, again, I would get back to +9. So there's no way that I can get back to the -9 without introducing an imaginary number. So what I'm going to do is simplify this. So we say x equals plus or minus the square root of -9. Now I'm going to separate the -9 into square root of 9 and square root of -1. Now we know the square root of 9 is going to be 3. And I'm going to leave this -1 because the only way we can replace that is by using an imaginary number. So I'm going to put this in the box over here, I is going to equal the square root of -1. So that's going to be the definition of I. So when I replace square root of -1 with I, the imaginary roots would be plus or minus 3i. All right, so when we consider imaginary roots or imaginary numbers, we're looking at the I. And it comes from taking the square root of a negative number, -1. Now, say for instance, we have I squared. I squared would be the square root of -1 times the square root of -1, or the square root of -1 squared. So we know that I squared would equal -1. Now, imaginary numbers come from the complex number family. So when we think of numbers, in the world of numbers, you can have real numbers and you can also have imaginary. Inside the real numbers, we can have rational and irrational. The set that includes real and imaginary are called complex numbers. So complex numbers have two parts. The first part is the A. The A is the real number. And then the I plus BI is the imaginary part. So when we write a complex number, it always needs to be in the form of A plus BI. So if you notice, for example, here we have -6 plus 4i. 7 minus I root 2. And we try to write the I and make sure it's clear that it's not inside the radical. You can see it as square root of 2i, but often people do not write this, and we try to stay away from writing it, and this year particularly, because when people write it, they'll often include it inside the radical, and we don't want it inside the square root. So to be safe, you could put that I right out in front. Now, in simplest form, if you have a equals 0, you don't need to write 0 plus 0.5i. Okay, so we try to simplify it. It's still going to be a complex number, and it's actually a purely imaginary number. Okay, so just like if you didn't have an imaginary part of a number, and this isn't written here, but if we say, a equals, we'll say a equals 5. And b equals 2. Oh, actually, we want to replace it with a 0. So we would just have 5, right? We wouldn't put 0i. We'd simplify that and just say that's 5. And 5 is a purely real number, and it's part of the complex numbers system. Okay? All right, now let's look at some operations with these complex numbers. We can add and subtract them. When we add and subtract them, we treat the terms almost like a variable, but they're going to be like terms. So we can only add real numbers with real numbers and imaginary numbers with imaginary numbers. So I'm just trying to write this out. So we're adding 4 minus 7i, and then we're adding negative 11 plus 9i, or a negative plus a negative 11. So when I combine, we want to write it in the a plus bi form. So I'm going to combine 4 minus 11, and that's going to be negative 7. And then I'm going to combine negative 7i plus 9i, so that's going to be plus 2i. And we're going to leave it just like that in complex form. For the difference, I'm going to make sure I distribute the negative, so it's going to be 6 plus 8i minus 2 minus 5i. So for here, I just need to make sure that I distribute this negative, and then I'm going to do the same thing, combine like terms. So real numbers go with real numbers, so 6 minus 2 would be 4. And then we have 8i plus 5i, which will be plus 13i. So we can add and subtract, but we try to keep all the real numbers with the real numbers and the imaginary numbers with the imaginary numbers. We can multiply complex numbers. So when we have something like this where it's negative 2.5i, we're going to have to distribute the 2.5i and make sure we multiply it with each term. So we have negative 2.5i, and I'm going to make sure I multiply that by 8, and then minus 2.5i times negative 9i. So simplifying this, I'm multiplying the negative 2.5 with the 8. So we get negative 20i. And for 2.5 times 9, that's going to be 22.5, and they're both negative, so plus 22.5. And then we have an I times an I, which is I squared. And remember, we said I squared was equal to negative 1. So this is going to be negative 20i plus 22.5 times negative 1. So we get negative 20i minus 22.5. Now just be careful because this is not in complex form. We have to write it as a plus bi. The imaginary part needs to come last. So I'm just going to rewrite them. So it's negative 22.5 will be first, and then minus 20i. Now for the next one, when we multiply, we're going to use the same acronym that we use for other binomials, FOIL. So for the first two terms, 3 times 3 would be 9. And then we have the outers, 3 times 2i would be 6i. The inners would be minus 6i. And then negative 2i times 2i would be negative 4, and then I times I is I squared. Now we can see right away that the terms in the middle are going to cancel. So 6i and negative 6i cancel each other out. And we're left with 9 minus 4i squared. Now remember, I squared equals negative 1. So 9 minus 4 times negative 1, well, that's going to be 9 plus 4, which equals 13. That's interesting. And we're going to talk more about this in the next lesson. But what you probably can notice, just looking at the terms, we have 3 plus 2i and 3 minus 2i. So we saw those i's disappear and we end up with a real number. I hope you enjoyed this lesson, and I'll see you all in class.